Ever pondered about the physical connections of WLAN components? Today we delve into this fascinating world. Welcome to our exploration of the Wireless Local Area Network, or WLAN for short. Its main components include access points, wireless LAN controllers, WLAN clients, and antennas. Each of these elements plays a vital role in the operation of your wireless network. The access point, often abbreviated as AP, is the communication hub. It connects your wireless devices to the wired network. The Wireless LAN Controller, or WLC, manages multiple access points, ensuring seamless connectivity. WLAN clients are your devices like laptops, smartphones, or tablets, while antennas help propagate the radio signals. Understanding the physical connections of these components is crucial for effective WLAN management. It helps you troubleshoot problems, optimize network performance, and ensure secure and reliable connectivity. So, ready to unwrap the mystery of WLAN components and their physical connections? Let's dive right in. Access points, often dubbed as the heart of WLAN. But why is it so crucial? Let's dive into the world of access points, or APs as they are commonly referred to. These devices play a pivotal role in a wireless local area network, or WLAN setup. But what makes them so integral? In the simplest terms, access points are the gatekeepers of your wireless network. They are the points of contact between the wireless devices, like your smartphones, laptops, or tablets, and the wired network. Think of access points as a bridge. On one side, they connect to the network through Ethernet cables, and on the other side, they provide wireless connectivity to WLAN clients. They manage the traffic flow, ensuring that data packets reach their intended destination. Now, imagine a busy city intersection. The traffic lights ensure that everything runs smoothly, directing cars where and when to go. Similarly, access points coordinate the data traffic, making sure that information from your device reaches the network and vice versa. They keep the communication between your device and the network smooth and efficient. Access points are also responsible for managing the WLAN's radio frequency spectrum. They control the signal strength, ensuring optimal coverage and minimizing interference. It's like adjusting the volume of your radio to get the perfect sound quality, except in this case, it's about getting the best wireless coverage. Moreover, access points support multiple wireless standards, including Wi-Fi 6, ensuring that your devices get the fastest and most reliable wireless connection possible. They are adaptable, capable of servicing a variety of devices from the latest smartphone models to older laptops. Lastly, access points are scalable. Whether you have a small home network or a large corporate network, you can add more APs to increase coverage and support more devices. They are the building blocks of a WLAN, capable of expanding and adapting to your wireless needs. So access points act as a bridge, connecting the wired and wireless world. But how do they receive instructions? Imagine a conductor guiding an orchestra. That's what wireless LAN controllers do for your WLAN. As we delve into the world of wireless networking, we come across a crucial component, the Wireless LAN Controller, or WLC. This device plays a pivotal role in managing and controlling the wireless access points in your network, essentially acting as the maestro of your WLAN symphony. So, what exactly does a wireless LAN controller do? It's responsible for network-wide wireless functions such as security policies, intrusion prevention, RF management, quality of service, and mobility. It allows network administrators to manage and automate these functions centrally, reducing the complexity and potential for error. Now let's talk about how a wireless LAN controller physically connects to access points. It's quite simple, really. The WLC connects to the access points through the network infrastructure. This connection can be wired or wireless depending on the specific network setup. This physical connection allows the WLC to communicate with the access points, adjusting their settings and managing their functionality as needed. And this is not a one-way street. The access points can also communicate back to the WLC, providing valuable data on network usage, performance, and potential issues. This two-way communication is crucial for maintaining a robust and efficient WLAN. But the wireless LAN controller does not stop there. It also provides advanced features such as load balancing and failover protection. If an access point becomes overloaded with too many devices, the WLC can redistribute the load to other access points. Similarly, if an access point fails, the WLC can quickly shift the devices to another access point, ensuring minimal disruption to the network. In essence, the wireless LAN controllers are the unsung heroes of WLAN. They work behind the scenes, ensuring that your WLAN runs smoothly, securely, and efficiently. They balance the load, ensure seamless connectivity, and protect your network from potential threats. Thus, wireless LAN controllers orchestrate the smooth functioning of your WLAN. But what about the devices that connect to this network? Now let's talk about the real users of WLAN, the WLAN clients and their antennas. WLAN clients are the devices that you and I use daily, such as laptops, smartphones, tablets, and other smart devices. These devices connect to a wireless local area network, or WLAN, using their inbuilt antennas. But what exactly is happening when we connect our devices to a wireless network? Let's break it down. The WLAN client, say your smartphone, uses its inbuilt antenna to send out signals searching for available wireless networks. This is similar to how we humans use our senses to perceive the world around us. Once your smartphone identifies an available network, it sends a request to connect. The access point, which we discussed in the previous scene, receives this request. If the access point allows the connection, a two-way communication link is established between the AP and your smartphone. This connection is wireless, meaning data is transmitted and received through the air using radio waves. How does the antenna come into play? Well, the antenna in your smartphone acts as the bridge between the device and the WLAN. It receives the radio waves transmitted by the access point, converts them into electrical signals, and sends them to the device's hardware for you to access the data. Similarly, when you send data, the antenna converts the electrical signals from your device into radio waves and transmits them to the access point. You might wonder, are all antennas the same? The answer is no. Different devices may have different types of antennas based on their design and functionality. Some devices might have single antennas, while others might have multiple antennas for improved performance and reliability. But no matter the number or type of antennas, their primary function remains the same: to facilitate the transmission and reception of data over the wireless network. They are the unsung heroes that make wireless communication possible. So WLAN clients and their antennas are the end users, enjoying the wireless connectivity offered by the access points. All right, now that we understand the physical connections, how about we configure WLAN access for client connectivity? Let's dive right into it. Setting up WLAN access using a graphical user interface, or GUI, is a straightforward process. For our purposes, we'll use Cisco's GUI, but the steps are similar for other vendors. First, let's open our Wireless Controllers GUI. This is where we manage our wireless network. Once we're in, we navigate to the WLANs section. This is where we'll create a new WLAN. Click on Create New and then Go to start the process. Next, we need to enter an ID for our WLAN. This ID should be unique and make sense for our network. Following this, we'll need to assign a name to our WLAN. This name, also known as the SSID, is what clients will see when they search for available networks. Now we come to the security settings. This is a crucial step because it's what keeps our network safe from unauthorized access. We need to choose the security policy for our WLAN. For maximum security, we'll use WPA2, which stands for Wi-Fi Protected Access version 2. It's one of the most secure protocols available today. We then configure the WPA2 parameters, including the encryption type and passphrase. The passphrase should be complex and hard to guess. Remember, a secure network is a happy network. After setting the security, we'll need to configure other parameters such as QoS, or quality of service, and radio policies. These settings help to optimize the performance of our network. Finally, we enable the WLAN by ticking the Enable checkbox. Once we hit Apply, our WLAN is up and running. Now any client device with the correct passphrase will be able to connect to our WLAN. They'll have secure access to the network resources, and we can manage their connectivity through the GUI. Remember, the process might vary slightly depending on the wireless controller and the specific network requirements, but the principles remain the same. And voila, that's how you configure WLAN access for client connectivity. Well, that was quite a journey, wasn't it? We've managed a complex world of wireless LAN components and their management. Let's quickly recap the key points we've covered in this episode. First, we delved into the role of access point serve as the crucial link between wireless devices and the network. Next, we explored the function of wireless LAN controllers, which act as the brains of the operation, coordinating the activities of multiple access points. Then, we examined WLAN clients and antennas and how their physical connections play a crucial part in ensuring smooth network communication. Finally, we walked through the process of configuring WLAN access for client connectivity using a graphical user interface. These components, when well understood and properly managed, can ensure the smooth operation of any wireless network. That concludes our exploration of WLAN components and their management. Stay tuned for more exciting journeys into the world of networking on TechSpectrum Pro.